When going hiking, we carry food with us. If we eat fruit, we throw the leftovers into the environment. The organic waste will naturally decompose into methane and carbon dioxide, and the remaining phosphorus and nitrogen will fertilize the ground. This almost magical event is the result of teamwork carried out by multiple microorganisms. What is the issue then? Worldwide, we produce 2 billion tons of waste per year, resulting in more than 1 billion tons of CO2 emissions, which is bad news for climate change. What if I told you that we can use nature in our favor? We can place the organic waste into a closed, oxygen-free vessel, add the right mix of microorganisms, and capture the methane, which can then be turned into electricity. This process is known as anaerobic digestion and is great for the environment. However, we do have other competitive sources of renewable energy, such as wind or solar power. To fight climate change, we need to stop using fossil fuels, but we are highly dependent on them, not just for energy, but for chemicals such as polymers, solvents, additives for cosmetics, and many more. Remember teamwork? In anaerobic digestion, there is a group of bacteria that metabolize waste into acids before they are degraded to methane. We call them volatile fatty acids, and they can be used in many applications. Currently, we produce them industrially using fossil fuels as raw material. Instead, we could obtain them from anaerobic digestion. But there are some challenges, like how do we stop the acids being degraded into methane, or bad bacteria taking over the good ones? I have been studying this closely in the laboratory, testing different conditions for this process, including pH, nitrogen content, and waste concentration. I found that alkaline pH can trigger higher acid yields, but the acids that we obtain are less profitable. Another issue is that when the acids are too concentrated, the pH drops too much and the bacteria die. This is where nitrogen compounds play a very important role. They can help maintain safe pH levels and provide nutrients for the bacteria. We still don't know everything about this process. There are many variables and many microorganisms involved, but we're slowly getting there. I hope that by the end of my project I can come up with some of the key strategies to make this process more efficient. This way, we can tackle fossil fuel dependency and waste management. Thank you for your attention.